The Chameleon prototype that we have developed at the University of Toronto explores a new style of interface concept that combines handheld devices, powerful computation with three-dimensional graphics, and spatial sensing. Here you see the Chameleon prototype in action. The inset pictures show you what the user is seeing on the handheld device. A 3D workspace with cubes inside it is being browsed by the user. The Chameleon is acting as a window or a porthole onto a large information space. Using rapid prototyping design, the Chameleon creates the illusion that the user is holding a powerful graphics workstation in the palm of his hand. The Chameleon is capable of generating 3D models and views through an understanding of its position and orientation in space. As the user moves the device or gestures with it, the device senses its change in position and orientation and reacts immediately. Here the user is browsing through a 3D information space that contains a cone tree. The user is able to visit individual nodes of the tree as well as zoom in and out of the tree. The effect of this interaction is to simulate the presence of the virtual cone tree structure in front of the user. By moving the handheld device, the user explores different portions of the cone tree. We are currently using an egocentric or eye-in-the-hand navigation metaphor. The kinesthetic feedback that the user experiences while browsing the structure also creates a better comprehension of the 3D information space. A clutch mechanism has been designed to bring portions of the workspace to a more comfortable gesturing space. By pressing the button and engaging the clutch, the user can navigate through the workspace. When the button is released, the clutch is released, and the Palmtop can be repositioned to a more comfortable gesturing space. The Chameleon prototype consists first of a small LCD screen. We then feed it a silicon graphics monitor and track its location with a 6D input device, the bird. A response button is attached to the top for additional input. Here you see the configuration of our Chameleon prototype. All of the components are combined to form a handheld device that serves as an input, output, and interaction conduit. Using the Chameleon system, we can investigate how everyday physical objects can be used as the interface to electronic information and computation. For example, a wall map may be used as an aid for navigation and orientation. When the Chameleon is positioned over a city, information for that city can be shown. Here the user is accessing weather information by clicking the response button. When the device is placed over the city of Toronto, for example, the user can get weather information or other forms of information like a street map of the city. We often interact with highly configurable and sophisticated devices such as this video editing suite. The Chameleon device may be well suited for offering spatially aware help and diagnostic assistance. The Chameleon can understand what device the user is focusing on due to its spatial awareness and provide help or guidance. For example, it could describe a functional overview of a device or show what specific controls do as the user actuates them. In addition, the Chameleon could tell about the internal state of the device. For example, what video input and output signals are currently connected to a device. The Chameleon prototype allows us to investigate tomorrow's interaction techniques with today's technology. Using integrated input and output, future Palmtops will provide many new capabilities based on the integration of physical and virtual artifacts within a 3D workspace. In the future, we want to explore how affordances of physical artifacts as user interfaces can be used to guide the interfaces and affordances of electronic artifacts. We are continuing to explore ways in which spatially aware computing can be utilized on a number of different scales using rapid prototyping and Wizard of Oz techniques.